Hello everyone and welcome back to the course. Today we will recognize when two statements say exactly the same thing in two different ways. Today we will uncover the secrets of logical equivalence. Some formulas, even if they're different, have exactly the same truth table. For instance, not P or Q and not P and not Q. We will see that these two statements have exactly the same truth table. Therefore, we will say that they are logically equivalent. This section will be all about exploring logical equivalences, and this will be done by analyzing truth tables of two different propositional formulas. And if they're identical, we will say that they are logically equivalent. We will start with our first example, which will be computing the truth table for not P or Q and not P and not Q simultaneously. So let's calculate the truth table. If we notice the truth value of not P or Q, we obtain false, 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 and true. Now, if we do exactly the same with the truth values of not P and not Q, we obtain false, 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 and true. Observe that the columns for not P or Q and not P and not Q are identical. This means that regardless of the truth values assigned to P and Q, both propositions yield the same truth value. Therefore, they are equivalent. Now we will analyze the truth table for the following propositional formulas. If P, then Q, and if not Q, then not P. We'll calculate the truth table for these formulas simultaneously. Again, we see that if P, then Q, and if not Q, then not P have identical truth tables, demonstrated that a conditional formula and its contrapositive, meaning if not Q, then not P, are equivalent, in the sense that they assert the same relationship. Formally, we can say that two propositional formulas are equivalent if they have the same truth table. We will use the following notation every time that two propositional formulas are equivalent. Logical equivalence is present in everyday speech. As a matter of fact, this can be noticed when two people are discussing and they say that they're basically saying the same thing, but each of them in two different ways. Another important property of logical equivalence is given by the substitution rule. Basically, this means that if A, B, C, and D are propositional formulas such as A is logically equivalent to B and C is logically equivalent to D, then the following rules hold. The first one is that not A is logically equivalent to not B. The second one states that C and A is logically equivalent to D and B. And the third one states that C or A is logically equivalent to D or B. Notice that in the second and in the third rule, we're basically substituting C for D and A for B. Now it is time to introduce a list of the most important logical equivalences used in propositional logic. Let us consider the following list of important logical equivalences. The first one is double negation, and it states that P is logically equivalent to not P. 2A and 2B states that disjunction and conjunction are commutative. Now 3A and 3B state that disjunction and conjunction are associative, whereas 4A and 4B represent the distributive law of conjunction with respect to disjunction and disjunction with respect to conjunction. 5a and 5b are called De Morgan's law with respect to negation associated to disjunction and negation associated to conjunction. Finally, we have two important logical equivalences associated to implication. The first one states that P then Q is logically equivalent to not Q then not P, and this is called contraposition. And the last one states that P then Q is logically equivalent to not P or Q. We encourage the reader to verify these equivalences by constructing truth tables. You will notice that in doing so, you will have a tautology. An important remark that we have to make is that logical equivalences can be used in propositional calculus, more precisely in rules of inference. This means that in the process of derivation, a propositional formula can be substituted by a logically equivalent one. And there you have it. This was the last lesson on propositional logic. Now you will be able to spot when two different sentences say exactly the same thing, and you will be able to say that they are logically equivalent. In the next lesson, we will start learning set theory. See you in the next lesson.